so 4.7 is about transformations of polynomials. So we have done transformations before with parabolas. Guess what? With polynomials, there's absolutely no difference. So let me go ahead and review the characteristics of transformations, okay? So we have different kinds of transformations that we've talked about in the past. And so let's start with the first one. Remember when we had a horizontal shift? How that appears is whatever function you have, whether it's a parabola or if it's a polynomial, all you have to do is take f and consider the shift directly against x. In other words, find f of x minus h. Another kind of transformation is a vertical shift. So if you have horizontal, you have the vertical shift. And the vertical shift happens if you have a function and you add a constant by either taking it up or adding a negative by taking it down. Okay. We had reflection. Okay. And there were two ways that we can reflect it. The first was over the x-axis. Okay. If you want to reflect something over the x-axis, all you have to do is take the function and negate it, and it'll reflect it over the x-axis. The y-axis, if you wanted to reflect a function over the y-axis, you had to put in negative x into the function. Okay, and we'll do a couple of examples in class, and also here. The other thing was when we had the stretches and the shrinks, both horizontally and vertically. So if you have a horizontal stretch, or if you had a horizontal stretch or shrink, okay, we can define it as such. So if you want to do a horizontal stretch, you're going to multiply x directly in the function by a factor of a. Now, if a is greater than 1, so if a is greater than 1, right? So if you had like 2x right here, okay, then what would happen is that you'd be shrinking it by a factor of 1 over a. Okay, and if you had a is less than 1, you would be stretching it by a factor of a. Okay, so that would be horizontal stretch. And then the last thing is if you had a vertical stretch or shrink, okay, and that happens if you take a, which is the factor, and you multiply the whole function by it, okay? And there's two cases in which it can happen, all right? If a is greater than 1, all right, then you'd be stretching it by a factor of a. Stretch by factor of a. And then the other cases, if a is less than 1, you would be shrinking it by a factor of 1 over a. All right? So this is just a general summary of things that you already know. We did these exact same kind of shifting, reflecting, and stretching and shrinking as we did with when we had with the parabolas. But now the only difference is that we're just elaborating it to polynomials. So let me go ahead and give you a quick example, okay? So let's just go ahead and say that we had a function f of x, okay? So if we had f of x, so here's an example. Okay, so if we had f of x and it was equal to x to the 4th minus x to the 3rd minus 1, okay? I want you, let's go ahead and see if we can find g of x, where it is a reflection over the x-axis. See if you can find h of x, where it's a horizontal shrink of 3. see if you can find r of x, where it's then translated by 2 units to the right. All right. And then s of x, where it is translated 4 units down. Okay, so here is one function that we start out with, and we're going to try to find all of these other transformations. Okay, so let's start with g of x, okay? So g of x is where we have to reflect over the x-axis, and we said that if we wanted to find g of x, okay, we have to find the negative form of f of x, okay? So if I were to negate the function f of x, it would be negative x to the fourth minus x to the third minus 1, and therefore it would equal negative x to the fourth minus x to the third plus 1. So this would be your g of x, all right? The next transformation that we're going to take a look at is h of x, and they're asking us for h of x to do a horizontal shrink of 3, okay? And the horizontal shrink, remember, if we want to do a horizontal shrink of 3, we need to consider, hold on, let me switch pens. So let's say we have h of x. Okay, what we're gonna do is we're going to take f of x, okay, and we're going to multiply the interior x value by 1 over 3. So it's going to be f of 1 over 3x. So I'm doing this independent. We could always build it on each other, but let's just say we wanted to do these transformations onto f of x. So if we do that, we would just simply put in 1/3 x into every value we see, okay, for x. X to the third minus 1. So if you clean this up a bit, you'll end up getting 1 over 3 to the fourth power is 81, x to the fourth, minus 1/3, that would be 1 over 27, x to the third minus 1. So this would be your h of x. And then for translating the function f of x 2 units to the right would be r of x. So r of x, what we have to do is we have to take x and we have to shift it 4 units to the right. So we would write it as such. Okay? And so wherever we see the x in our original function here, we would simply sub in x minus 2 minus x minus 2 to the third minus 1. Okay? And that would be our r of x. And last but not least, we would have, let's see, s of x. S of x, we have to translate it 4 units down. So s of x, hopefully you can see this, is just going to be the function, okay, plus k, which is 4 units down, which is minus 4. So it's going to equal negative x to the fourth minus x to the third minus 1 minus 4. And so our result is going to be negative x to the fourth minus x to the third minus 5. All right? So I think what you can see is when you, hopefully if you want to test it out, you can plug in these different equations in addition to f of x and just see how f of x hopefully gets reflected in this case, gets horizontally shifted or shrank in this case, gets translated 2 units in this case, and then also gets shifted down in this case. You could try that on Desmos. If there's any questions or comments, feel free to post onto Google Classroom.